Hi everybody, this will be a video explaining differences between mixtures and pure substances. In particular, we will discuss classification of different substances that I give you a list and you have to figure out which is which. Now just to recap very quickly before we start. In class we've already discussed the differences between a pure substance and a mixture. We've talked about the fact that pure substances are the same throughout. They have some kind of a chemical designation, either a chemical formula or a chemical symbol. If you have one substance only, one atom only, one kind, it's an element. If you have two or more elements, it's a compound. Now, mixtures are a combination of compounds and compounds, compounds and elements, elements and elements. Mixtures can also be subdivided into homogeneous or heterogeneous. And they are different in how they look and how they behave. Homogeneous means the same throughout. Heterogeneous means that they are different. The picture that I've shown you here on this very first opening minute of the video comes from your booklet. I don't believe, however, that your booklet's in color. So I want to elaborate on this picture and help you to get these concepts into your head. Let's start on the far right-hand side. This is a picture on the far right-hand side of gold. And it's depicted by gold-colored balls. And you'll note that all those little balls are the same, they're the same color, because the element of gold is made up of only one kind of atom, gold atoms. The next circle over contains, as you can see, substances that have two white and one red ball stuck together. There's a whole bunch of those units, which we call molecules. If you look at the picture above, you can see that that's meant to depict water. As you know, water is H2O. So the two white balls would be the H's, and the one red would be the oxygen. Every single substance in there is the same. Two white and red, two white and red, two white and red. Water molecules. Now, at the bottom of the mixture flowchart, what we have are two different kinds of mixtures. Let's start with homogeneous. The picture above it is what they call a saline bag at the hospital. Contains sodium chloride in water. The picture clearly shows two white and red units. They're together, held together. Those are your water molecules. It's a compound of water. And you will also see there are some green and some blue atoms spread apart amongst the water. Note that they're spread apart evenly and that they're not really all together in one spot, but they're throughout. Compare that to the heterogeneous mixture on the left, which is meant to show oil and water. On the bottom, again, more two white, one red units. On top, you'll see very long chains of molecules having black and white balls. And those units are basically very long chains of carbons and hydrogens all bonded together. Those are what oil molecules look like. And they're big, and they actually have a color. If you see enough of them together, they're yellowish. And note the layer. They're separate. One is heavier than the other, and eventually they will form two layers because they do not mix. They are immiscible. There's a new word we learned in the last week. So heterogeneous, different throughout. Homogeneous, the same throughout. Compounds and elements are both pure substances. Compounds contain two or more elements. This picture you see in front of you comes from your booklet as well on page 9. But again, it's not colored. I'd like to discuss what you're seeing in front of you. The options are here to identify which of these boxes, A, B, C, or D, contains an element, which contains a compound, or which contains a mixture of substances. What I see in the far left for A is I see only one kind of a substance, red balls basically. That would indicate that that substance has to be an element. All the same thing. Now B is similar in that it contains only blue, but I want you to note that there are two blues stuck together, which means that it's a little set of two atoms that are identical. We learned what those were called in class on Thursday, recently. Those would be diatomic elements. For example, it could be a hydrogen, it could be an oxygen, it could be a fluorine, a chlorine, an iodine, any one of the Hofbrinkels it could be. There are two elements held together in a pair. Those are specifically a good picture of any one of the diatomic elements, those 7 special cases. Now C, you can see again, 2 white, 1 red, therefore different elements, together in units, therefore that would be an example of a compound, most likely again water. D contains different things together. D is a mixture. D is a mixture of, let's just say, 2 gases. Because they're not touching, I could say that those would be, that could be steam. That could be steam, and it could be oxygen in the same container. It could be anything, depending on what you choose for your atoms, as long as they're one of the diatomics for the blue. But that's an example of a mixture because it has different kinds of substances held together. Now the next slide is an exercise. I want you to classify each one of these substances as either a pure substance or a mixture. And once you get it down to a pure substance or a mixture, I want you to subcategorize them into either elements and compounds or homogeneous or heterogeneous. If it's a mixture, I want you to pause the video, do them first, and then come back and play it and see how you did. Okay, the answers are coming up. A, lemonade. Now lemonade is either a pure substance or mixture. It's not a pure substance, it's a mixture. Now if it has no pulp, that would imply that it's the same throughout, and that would make it homogeneous. I'm not going to spell the whole word, just the prefix homogeneous. Mixture, and it's homogeneous. B, octane. Octane is obviously, when I give you in brackets a description, you can see it contains 2 different kinds of elements. So it's a pure substance, but specifically it's a compound. Manganese for C. Manganese is an element in the periodic table. It's a pure substance, but it's also an element specifically. Contact lens cleaner. Contact lens cleaner is water-based solution containing some substances that are dissolved in it. And because it is a water-based, and because it has substances dissolved throughout, it's definitely a mixture. And specifically, there's no bits you have to pick out of your, you don't pour it into your hand and pick out bits. It's the same throughout. So it's homogeneous. That can't be said for Raisin Bran. Raisin Bran has 2 scoops. This is a mixture. And because it is different throughout, it's an example of a heterogeneous mixture. Raisins and flakes and God knows what else. Acetaminophen, you would say, well, I'm not really sure if it's a mixture or a compound, but the minute you see the chemical formula, you can only have chemical formulas for compounds. You can have chemical symbols for elements, but a mixture would have a blend of different kinds of compounds, or compounds and elements. This is an example of a compound, and this compound, of course, is a pure substance, It contains carbon, hydrogen, nitrogen, and oxygen all held together in one big unit. And lastly, blood. Blood could be a very debatable substance. The question is it a pure substance or is it a mixture? Well, blood contains many things. Blood contains water, blood contains red blood cells, white blood cells, it contains platelets, it contains salt, it contains iron. It's definitely a mixture, all those different components. The question really becomes, is it homogeneous or heterogeneous? And that completely depends on when and how you see the blood. If it's fresh blood freshly pulled, then it's going to be homogeneous. If you look at it under a microscope, it's heterogeneous. If you look at it after it's settled after 5 or 6 minutes, it might go distinctly into layers. It's heterogeneous. That one could be debatable on your perspective when you see it. But the fact that it can be under a microscope, pretty likely to be hetero. But if you have it in a vial and there's a thinner in it and you can't see the components, then you could also argue that it's homogeneous. I don't tend to ask questions like that on a test situation. They're great for classroom discussion, but not for tests because they are debatable. So trust me that I'll try to ask questions that you won't be able to argue over. The next page has another exercise. I'd ask you to pause, try these, and come back. Okay, vinegar. Vinegar, if you can picture in everyday life, it is a very potent substance dissolved in a water-based solution. It's a mixture, and if you're buying vinegar, it should certainly be homogeneous, not heterogeneous. You do not want bits in your vinegar. You can get stronger vinegar, you can get weaker vinegar. It depends very much on what you buy. Most vinegars are a 5% solution. Homogeneous. Trail mix, not a pure substance, not the same everywhere. It has variety. It's a mixture, and there are different components in it, so that screams heterogeneous. 18-karat gold. I didn't just say gold. If I just said gold, you would say definitely an element. The fact that it says 18 karat would signify that it's jewelry, that it is a blend of different components in the gold. It's going to have gold, it's going to have some silver, probably a little bit of copper, maybe a little bit of zinc. I can't remember the exact ratios, but they're available anywhere online. Definitely going to have more gold than anything else. It'll be softer than 10 karat gold, but it's definitely a mixture. You do not want to have different components visible in your gold. Same throughout. Don't forget the key word for special kind of mixtures of solids and solids that are metals. Gold. This gold is considered to be an alloy. Nice little test word. Kool-Aid. Kool-Aid. In my house, we made a lot of Kool-Aid when we were kids. Kool-Aid typically contains sugar, water, and a whole bunch of food coloring crap. And it's the same throughout. It's a mixture. And it's also homogeneous. Baking soda. It's actually a very simple substance. It's a pure substance. It can be described by a chemical formula, which makes it a compound. You have some likely in your kitchen. Aspirin. Aspirin also has a chemical formula, and aspirin contains 3 elements, carbon, hydrogen, and oxygen. It is also an example of a compound. It contains 2 or more elements. Compound. Tap water. Don't be fooled by this question ever. The minute you throw in the word tap water in front of water, it's not just simply this. It's probably going to have faint amounts of chlorine because it was probably treated somewhere. If it's not, if it's well water, for example, it's going to have some minerals. It could have some iron, it could have some magnesium, it could have a whole bunch of minerals in it. It could have some salt in it, actually. Then you put the word tap in front of it. It's not pure. It's a mixture. And some tap waters could even have sediment in it. When I think of tap water, I think of palatable drinking water that has no solid particulate matter. I think of it as being homogeneous, but we all know you could pour tap water, if it's from a bad source, have it sit in a glass, and it could settle with a smudge in the bottom. If that was the question, that would be heterogeneous. But typical good quality tap water should be homogeneous. One more exercise. Exercise 3. Give it a try first, and then come back and see how you did. Pause the video. Okay, part A says iron filings. Now that simply is a sample of iron that's been shaved with some type of machining down to little small pieces of iron. It is still iron, therefore it would be an example of a pure substance, specifically an element. Concrete. There's a lot of different varieties of concrete out there. Because there's a lot of varieties, it's definitely not going to be a pure substance. Variety always implies mixtures. Concrete, you can quite often see the rocks in the concrete. There's different grades. So when I think of concrete, I think of hetero. That I suppose could be argued, but that's my perspective on that one. Air. Air is not a pure substance. There's not one chemical formula that you can give to air. Air is a blend of many different components, and there's lots of different qualities of air around the world. It's typically a homogeneous mixture, the same throughout, but you could take a sample of air at one side of the room and another side of the room, and because there is variety, that would confirm the mixture diagnosis. Mostly nitrogen, some oxygen, and other substances in that. It's a gas-in-gas mixture. And sometimes there's even, of course, pollution and all kinds of other things. Ibuprofen is a pure substance. It's always the same everywhere you go. Ibuprofen is ibuprofen. And if you want to buy the Walmart brand, or you want to buy the high-end brand, usually known as Advil, it's the same chemical formula. It is a compound, and it is a pure substance. Contains carbon, hydrogen, and oxygen. Paint can often start quite a discussion in a classroom environment. Paint is depending really on your perspective. When I think of paint, I think of a beautifully freshly purchased can of paint that's been recently shook, and it's lovely opened up and put on the wall. Somebody else's perspective could be an old, can of oil paint that's settled over time. So if you had a qualifying word in front of that and said a freshly shaken can of paint, then I would pretty much think we could come to the conclusion it would be a homogeneous mixture. If it was an old can of paint, we would probably debate on it being hetero or having settled. I won't ask dirty questions like that. On a test, I make it clear, but for a class discussion type question, you could argue both. Rhodium may not be familiar, but it's an element on the table. Rhodium is actually quite prevalent in white gold. It's part of the coating used to keep it from not corroding, but wearing down, I think. Italian salad dressing has lots of bits. It's a mixture, and because there are bits and it will settle, it's hetero. Glucose, you'll notice from class, very similar to glucose, which you should know, C12H22O11. Glucose is actually half of a sucrose molecule. Glucose and fructose, in fact, join together to make a sucrose. Glucose is added to water to make a solution. As it is right here, it's compound. If you add it to water and it dissolves, That is often what they call brain food, so to speak. A person can be kept alive by having glucose in a bag in water solution and fed intravenously. That can be enough fuel to keep you going for a little bit of time. It's the sugar that gets into your blood, that gets into your cells, that insulin has to help in, but glucose is pretty common compound in your life. Anyway, it's a compound. It could be dissolved in water, become a mixture. The last diagram in this little video I stole from the internet, and it's a nice little one. I like it a lot. At the top it gives instructions, and it says, the following diagrams, classify them. A simple substance, i.e. an element, a compound, a mixture of simple substances, a mixture of compounds, or a mixture of simple substances and compounds. Let's just scan and take a look at these. So when I see this diagram, what I see is, of course, a whole bunch of different colors. The first thing I notice in the upper left are blue colored atoms, all nice and neatly arranged. They're all the same. To me, that's an element, a simple substance. In fact, not only is it an element, but I can also go further and say it's a gas. It's a solid, rather, because they're all nice and stuck together. When I scroll and look, I see, for example, this slide with the orange and blue, or purple, whatever color it's supposed to be, as a compound. And each little unit contains one orange and one purple. I see a compound down the far right-hand corner containing two different kinds of elements, blue and brown. I see a compound here containing two green and a purpley color. I see, scanning and looking, I see the second one, red and green, as a mixture of elements. Different kinds of elements. I see the far right as a mixture. And that mixture over here contains two different kinds of single elements, orange and brown. And then I see these diatomics, little double pairs. I see this blue one as a weird little bird. I see three atoms together, all same color, but they're little units. And that's actually probably meant to represent ozone, which is O3. Three oxygens together, which would be considered a special kind of weird case of a little molecular type molecule. I see down here a compound and an element mixed together. Over here, I see a mixture of singular elements and diatomic elements. For this particular picture, I see two different kinds of compounds. One that contains three atoms and one that contains two atoms. Same over here. I see a mixture that contains a compound with 5 atoms. So all kinds of weird ones in there. Quite a mixture. And up here on the top, we have some diatomic elements and we have some compounds. So I hope that this little video has helped you to break down unknowns or knowns into mixtures and pure substances, and further subdivide them into elements or compounds, homogeneous or heterogeneous. Think about a couple questions. Can the substance be separated physically, like by distillation or filtration or boiling or melting? Can you get things separated that way? Mixtures are always physically separatable, and compounds can always be broken down using some kind of chemical means. Elements cannot be broken down by any chemical means, physical means, or any means. Only by nuclear reactions can you break apart an atom. So, good luck. Enjoy your studying.